All right, so the next question we are dealing with is question number 21. We are still on the Oxford series of non-directional beacon. Let's look at question number 21. The ADF of an aircraft on a heading of 189 degrees true will experience the greatest effect due to quadrantal error if the Ndb bears. All right, so we know that quadrantal error is one of the unique errors of non-directional beacon. Coastal refraction is yet another one, and static interference, for that matter, it's one of the most significant errors in Ndb. Right? Quadrantal error, the primary reason for that is the electric field that is produced by the fuselage of the aircraft, the body of the aircraft itself along the fore-aft axis, and that causes the radio waves coming from the non-directional beacon to kind of deflect towards the fore-aft axis. So we know that from the theory, if you have actually gone through, the amount of quadrantal error is felt maximum on relative bearings of 45 degree, 135 degree, 225 and 315 degrees. So in here you are given the heading in true, which is 189 degrees, and you're asked to find out of the four options which of these options have a bearing where the error would be maximum. All right, so we are trying to find out the different bearings using the relative bearings that we have and the heading which is given in the question. So what we're trying to do here is to draw a small picture of the aircraft. I'm not depicting the aircraft with respect to the actual true direction system, which means I will not be aligning the nose of the aircraft exactly towards 189 degrees. I'll be just drawing a random convenient direction, and because the whole idea is to find out the bearings, right? So let's draw a miniature aircraft here to begin with. So we have the visor, and now it's pretty much clear from the theory that the quadrantal error depends on the heading of the aircraft, and heading is more the direction in which the fore-aft axis, or more appropriately called as the longitudinal axis of the aircraft, is aligned. So let's kind of depict that first. This is the longitudinal axis of the aircraft, and therefore this would be a heading of 189 degrees. It's usually practically expressed in magnetic headings, but in the question it's given true. But doesn't really matter as far as the question is concerned here, right? Now this axis is what is called as the fore-aft axis of the aircraft, and in technical as well as in other general discussions, you would have heard the term longitudinal axis, which is nothing but the fore-aft axis. So it's also called as the longitudinal axis of the aircraft. Now we're looking at four different relative bearings here. So relative bearing is a bearing that's always measured from the nose of the aircraft, always clockwise. So this is the aircraft here, right? From the nose you can measure clockwise, and that's what is called as the relative bearing. The actual heading itself doesn't affect this value. What affects this value is basically the relative position of a particular waypoint, another aircraft, whatever it may be, with respect to the nose of the aircraft, right? You can be on the same relative bearing at different headings, right? All the basic understanding, I hope you have that in place. All right, now, so having this picture in place, let's kind of now draw the four main relative bearings at which this quadrantal error would be maximum. So the first one is a relative bearing of 45 degrees. Let's depict that here. So this is an angle that is measured clockwise from the heading of the aircraft, 45 degrees, and hence called 45 degrees relative. The next relative bearing would be 90 degrees from this 45 degree relative, and that's going to be 135 degrees. So let's draw that. This is 135 degrees of the heading to the right, means to the clockwise, right? This is a relative bearing of 135 degrees. And now we have the third relative bearing that is kind of opposite to the 45 degree relative bearing, and that's going to be 225 degrees relative. The fourth relative bearing would be exactly opposite to 135 degrees relative, and that's going to be 315. Just rearrange 135 and you will get 315. Right. These are the relative bearings at which the quadrantal error would be maximum. Now, if you zoom back to this question, what is asked in this question is not the relative bearings at which the error is maximum. Instead, what's asked is the actual bearings where the error would be maximum. No, pay special attention to this particular statement here. If you're asked to find out or to pick up the relative bearings where the error would be maximum, it doesn't really depend upon the heading. It's always either 45, 135, 225 or 315. But in this question, you're asked to find out specific bearing with respect to the heading where the error would be maximum. Therefore, to find out the bearing, we have to add this relative bearing to the heading, and that's going to give you the QDM, right, which is the magnetic track to the station. And since it is true heading given here, it's going to give you QUJ, which is a true track to the station. All right, let's find it out. With a heading of 189 degrees over these relative bearings, it's going to be a bearing of 189 plus 45 degrees, that is heading plus the relative bearing, and that's going to be 234 degrees true. Over a relative bearing of 135 degrees with a heading of 189, it's going to be 189 plus 135, and that's 324 degrees true. It is just 90 degrees clockwise from 234 bearing. All right, now over a relative bearing of 225 degrees, it's 189 plus 225, 54 degrees. True again. Now remember, when you add 189 to 225, the immediate answer is going to be 414, and we know there's no 414 direction as under the true direction system, so we have 0 all the way to 360 degrees, so you can subtract 360 from that to get 054 degrees true. And finally, on a relative bearing of 315 degrees from a heading of 189, it's 189 plus 315, which is 504. Remove 360 from that and you'll get 144 degrees true. All these are the true tracks to the station, which is more like the QUJ. So quadrantal error is primarily because of the influence of the fuselage on the body of the aircraft, producing electric field oriented in the fore-aft, or more appropriately called as the longitudinal axis of the aircraft. This kind of refracts the radio wave, the incoming radio wave from the Ndb towards the fore-aft axis, and that's going to be maximum around the relative bearings of 45, 135, 225 and 315 degrees true. I hope this question is pretty much clear to you as far as the conceptual foundation is concerned. So we have 4 different bearings at which the bearings, the error would be maximum. That's going to be 234 degrees, which is here. We have 324 degrees, 54 degrees and 144 degrees. We also have 4 different relative bearings at which the error is going to be maximum, which is the relative bearing of 45 degrees, 135 degrees, 225 degrees and 315 degrees. Understand the difference between the actual bearings and the relative bearings. See for what is asked in the question before you pick up the answer. Right? Now let's get back to the options that is given in the question. So we have 4 different options, starting with a 234 degrees true being the option alpha, and we do have 234 in our options, and therefore this could be the right answer. 279, definitely not. 225, no. Remember, if you look at 225 here, this 225 is not the bearing at which the error is maximum. 225 is the relative bearing at which the error is maximum. So this is more like the relative bearing at which the error, the quadrantal error, would be maximum. So be very, very careful for what they have asked in this question. In this question, you can see they have asked us to find out the bearing at which the Ndb is going to produce the maximum error, not the relative bearing, right? 225 would have been the answer if the question asked for the maximum error at the respective relative bearing. Now the last one is 145 degrees. Look at the last bearing that we got is 144, and therefore 145 is definitely a possible answer, but since we have 234 up there as alpha, that is definitely the closest answer. Now having said that, even at 145 the error is going to be pretty much high, because it's 144 is going to be maximum. So 145 is definitely not, it would not be a wrong answer if 234 was not there. So as of now, alpha is definitely the answer. This alpha is the bearing at which the quadrantal error would be maximum if the aircraft is at a heading of 189 degrees true. Pay special attention to options Charlie as well as Delta. All right, I hope this question is pretty much clear to you. Let's now go into a different kind of question from Ndb itself. An aircraft is flying a heading with 12 degrees starboard drift and